Hi, so we're just going to continue where we left off. So with notation for infinite or too large to list sets. So we're going to introduce a few methods here. So this is method 1. And in method 1, what you're going to do is you're going to just list enough elements until it's clear. And then you're going to kind of put dots after that. So list enough elements so that the pattern is clear, then write dots. So let's actually kind of look at some examples of this. So we have, okay, so these are examples. So if I just wrote for you 1, 2, 3, and then I put a whole bunch of dots, remember that, right, we put this on the outside of sets, okay, then you would probably be able to guess what this says, that this is just a set of all positive integers. Right, and then if I wrote, so this is going to be a little different, so if I wrote -2, -4, -6, please don't panic, I know that this is not in the order, it would be on the number line, that this would be the set of all negative even integers. So here we have that they're negative and they're even. And as I mentioned before, it's totally okay that this is in the non-standard order. Right, we just needed the patterns clear. Non-standard. Right, we just need that the pattern's clear. Which hopefully it should be, just what we wrote there. Okay. Now something else we could do is we might have a set that's going to kind of continue on both sides, and that's okay. You just put dots on each side and still make sure that the pattern is completely clear. So I'm going to say, what if I do the set, and then I put dots over here, and then I went -3, -2, -1, 0, 1, 2, 3. So you'd probably get the point from that now I'm looking at all integers. Right, and again, having dots on both sides just means that I continue in both directions. Okay? So there is a key point here, though, which is that I actually need to list enough elements so that the pattern is clear. Okay? So, but please be careful to list enough elements to make the pattern clear. So let's look at an example of what I mean by that. So let's say that I wrote, I started out great, but then I just only wrote 2 things there. So there's ambiguity, right? Is this, right? So then one could ask, is this the positive integers? Is it powers of 2? There's no way to know. Right, so we look at that as pretty unclear. You want that there's kind of no ambiguity in what you might be writing. Okay, so the next method, that I'm going to introduce. So that was the one where we list enough elements so that the pattern's clear, and then we just put dots after that, or maybe before if it goes in both directions. So here we go. So we're going to define a set using a rule. I'm going to kind of color code this, so I'm going to put an A over here, so we have A, and then we have B. Okay, so what does this mean? This means so this is the set of all elements of the form A which satisfy the condition B. Okay, that might seem unclear for the moment, so let's show you some examples. And let's erase that to give ourselves a little bit more room. So examples. So as the first one, okay, so I start with my curly there. So the set of all A, such that A is a positive integer. Right, so that's going to look like, right, we just write 1, 2, 3, and so on. I remember to put the 3 in there so that this was clear. So here's the notation we have for that, right? If we're in Canada or the US, in other countries, maybe you're going to include 0 in there. That's something to watch for. Okay, so this is the set of all A. I'm going to kind of highlight that that's what goes there, such that A is a positive integer. Right, and that A is a positive integer, right, is the part that's over there. So basically, I start with the set of all, and so that comes from here, and then, right, this part just kind of falls there, this basically turns into a such that, and then this goes over there. Great. Now, we have the set of all A and R such that A squared equals 2. Right, well, what are all the real numbers where when I square them I get 2? So we're not going to forget that because I said all the real numbers I'm allowed, I can put minus the square root of 2, and then also the square root of 2. And if you thought about that kind of for a moment of what I said there, this is a key point, which is that here it really mattered that A was an R, or it could change this, and I'll show an example in the future. The other thing that I want to note about this is that this is a finite set. That's okay. I know I said that this is like notation for, I know I said this is notation for infinite sets. It's perfectly fine for finite sets too. Okay. So this is a finite set. That's okay. Same notation works for finite sets. But you still, again, need to make sure the pattern's clear, and so in a lot of cases you're actually going to have to list everything. But maybe not. Maybe like knowing what are on the end sides is enough with a few dots in the middle. Okay. So here we have that this is the set of all real numbers A such that A squared equals 2. Okay, and again, you can see that this part here, the set of all real numbers A. Okay, so that's what comes from over here. So I could say the set of all A in the real numbers, which would have been a direct translation, but we're going to be okay with that. And then over here, we're going to have such that, and then we have A squared equals 2. And then I wanted to really quickly show you, this is a circumstance where it kind of can matter what's over there. So let's do that really quickly. So note our requirement that A is an R, right? Can have an impact on the set. Okay, so for example, if I said the set of all A in R, but I put greater than or equal to 0 there, right? And I'm still looking at where A squared equals 2, right? Then what ends up happening here, well, I'm requiring that the real numbers, I'm only looking at the non-negative real numbers right now, and so I'm actually only going to pick up the positive square root of 2. So this is the set that has one element. That element is the square root of 2. And then if I write here A in the integers, well, now I run into trouble because I can't ever square an integer and get 2, right? So what do I get here? Well, this is this special empty set, right? Okay, and this is, since there exists no A in the integers with A squared equal to 2, right? My only options are minus the square root of 2 and 2, and those are not in the integers. Okay, I want to, so that's kind of an emphasis on the fact that, telling me where, your variable's allowed to lie or whatever's allowed to lie from that side can actually have a big impact on your set. Now, there's one other kind of way of doing this a little bit that I don't like, but I want to show you because I'm not the only human being in the world that might teach you math. So if we have B squared on that side, and B is an integer, okay? So this, to us, well, what does that look like? Well, okay, I'm going to have, right, so I could get 0, I can get 1, I can get 4, I can get 9, I don't get anything negative because I'm squaring, okay? And that's kind of fine. This still works with the same thing where I say that this is the set of all B squared, so I'm putting in, right, all of these options, and by options I mean, so now I have this such that B is an integer. Okay, and that's all the examples that I wanted to do this, and then I encourage you to kind of look at the pre-quiz now as maybe a little extra practice with this.